For question A, I'm going to write off to the side g of x is equal to y, which means that as a point, this is my x and this is my y, if I wrote it as a point. Where is x? 2. So 2 is up 1, 2, 3, 4, 5, 6, 7, 8, 9. 2 is up 9. So I would say that g of 2 is equal to 9. Where is g of 0? Here's 0, it is up 1. 1 is my graph, the height of 3. So where is g of x equal to 3? 3 is when x is a 1. Write the explicit rule for g of x. That would be g of x is equal to, it starts at 1, and then it goes to 3, then to 9. That is multiplying by 3 each time to the power of x, or you can say x minus 0. H of 0. Same thing, h of x equals y, so the point x. Where is x 0? 1, 2, 3, 4, 5. 0 down 5. Down 5. Where is 3? 1, 3 is down a half. So I'm going to say down 1 half. And I have, when is it at a height of 1? For y, 1, 2, 4, 4, comma 1, 4, comma 1. So x would have to be 4. And where is it the height of negative 2? 2 is down 2. So negative 2 would be at when x is positive 2. And if it wanted me to write an explicit, I would say h of x is equal to, my slope is up 3 over 2, and my y-intercept is at negative 5. Given r, function r of x, r of x is equal to y, as in the point xy. When is it negative 1 for the x? It's up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Negative 1 is up 10. Where is it when it's a 2? 2 is up 1. Where is it a height of 4? 1 is up 4. So whenever it's a 1 here, it'll be at 4, so x is. What is the rule? R of x equals my slope. This point is 7. It goes down 1, 2, 3, down 3 over 1 with my x for slope, and it crosses at positive 7 for the y-intercept. You do not have to put negative 3 over 1. You could just say negative 3x plus 7. I am given f of x equals y, as in the point xy. Where is x? 4. This is where x is 4, and it is up 1. So let's say it's up 1. Where is it? Negative 4. Here's negative 4, and it is up 1, 2, 3, 5, 6, 7. Now it asks, where is it the height of 4? That point is 0, 4. 0 up 4. So my x would be a 0. Then it asks, where is it at the height of 7? We already found that the height of 7 was at negative 4. So when there's a negative 4 in here, it's at 7. And there's a 0 in here, it's at 4. To create my equation, I would find the y-intercept and the slope. My slope is going, let's see, where does it intersect? Right here. 1, 2, 3 over 1, 2, 3, 4. Down 3 over 4. And my intercept was at a positive. For question C, we are determining if the representation is discrete or continuous. Our first one says Susan puts exactly $5 a week in the piggy bank. This would be discrete. She would be counting her money. In this next one, the bouncy ball and its price, they are dots, which means it is discrete. And the solid line represents a measurement. Temperature is a measurement over time. This would be continuous. Determine the domain and range and whether the relationship is a function. For this, my domain are x values. So I'm going to get my x's and write them in order. So I'm just going to say negative 7, and it would be negative 6, then negative 2, I'm just writing them in order, then 3, and 8. Those are all of my x's. That's my domain. Now for my range, I'm going to do the y values. So my smallest number is 2, then 3, then I have a 4, then I have a 5, and another 5. Now, if I type this in, it'll mark it incorrect. I do not need to type 5 twice, so I will just write it with 1, 5 in the list to represent that is the range from 2, 3, 4 to 5. This one would be a function. Functions are determined by the x values. There can only be one of each number. This would be a function. If the domain had had two -7s, it would no longer be a function. It only have one of each x. No x's in it. For my next ones, I have explicit equations. If I want the domain and range for explicit functions, I can graph them. Let's see. So, Desmos. So you can download the Desmos graphing calculator. It is free. When I graph f of x is equal to -2x plus 7, you will notice that my graph is linear and it continues left infinity and right for infinity. So I'm going to write a graph. 1, 2, 3, 4, 5, 6, 7. And it goes down to the line. So my line on my graph looks like this. That means for my domain, it continues to the left, which would be -infinity, and it continues to the right, which would be positive infinity. For the range, that is the bottom to top, up and down. -infinity, it continues going down and it continues going up, which that's a positive infinity. Going positive numbers. So the lowest it goes is -infinity, the highest is positive. If I graph g of x, I'm going to say that I have 3 times 5 to the power. I'm going to replace that 2 with x. So here's my graph. It crosses at 3. And if I times it by 5, it would be up to 15. And it curves down to kind of match my graph. It crosses at 3 and flattens out. My domain, it goes to the left infinity and right infinity. My range is different though, because it stops at 0 and goes to infinity. We are looking for domain and range. Domain are the x values, so -4 to 0, and they're closed dots, so I need to do brackets. Then I have 1 to 3. And this one is 4 to 5. That's my domain. So I have 3 different domains for each one. Then my range, I see how low it goes. -4 is the lowest, and it's a closed dot. Then it goes, do you see how there's a line here? -3 counts, -2 would count, -1 would count because it's touching all those points. This is touching all the points, touching all the points. There's no gaps so far, and then it stops. So it goes up to 2. That's my height. So my range doesn't have any gaps between them. Where my x is, do you see how the x had a gap here and a gap here? That's why they're separated differently. On our next one, we have arrows, which means it continues to the left and continues to the right. That's -infinity to infinity. And the range would be how low it goes and how high. As you notice, it keeps going down and it keeps going up. So it's also -infinity to infinity. My domain, it continues to the left, so we'll go to -infinity. It keeps going, but it stops at 1, 2, 3, and it's an open dot. So it goes from -infinity to 3, and I use a parenthesis for the open dot. My range, the lowest it goes is -infinity. It keeps going down, and the height that it goes is 3. -infinity to the height of 3. Domain, it continues to the left, -infinity, right infinity. The arrows indicate it continues. The range, as you see, it keeps going down, but this one flattens out at 4. So my low is -infinity, and my height, as it flattens out, is approaching 4. Next section is a word problem. Fran collected data on the number of feet she could walk each second and wrote the following rule to model her walking rate. So it's 4 times the time. What is Fran looking for if she writes d of 12 equals? She is looking for how far she walks in 12. Time is measured in seconds. So what I would do mathematically is I would take that 12 and plug it in for t, which would give me 48. So in 12 seconds, she walks 48 feet. In this situation, what does d of t equals 100? Well, t is time, so this means distance in feet. If you wanted to solve it, you would say 4t equals 100. Well, if I divide by 4, that means my time is 25 seconds. How can the function rule be used to indicate a time of 16 seconds was walked? Then I would write the time is 16, and then I would plug that in to see what it equals. So 4 times 16 is equal to 4 times 6 is 24, 64. 64 feet when there are 16 seconds. How can the function will be used to indicate that the distance of 200 feet was walked? Via t equals 200 feet. That means the 4t equals 200. Divide by 4. T is equal to 50, which means 50 seconds. 50 seconds gives you 200 feet walked. Describe features of functions from the graphical representation. For each graph, provide the following. So, decreasing, increasing, minimum, maximum, domain, range. And write them on the following so we can just go through. Okay, and on the bottom one, I'm going to write these ones in 2. Decreasing, increasing. I'm going to add in constant. Min, max, domain, and range. Once we fill all of these in, we will be done. So this graph, as I read left to right, it is decreasing the entire time. To say that it's decreasing, I would say negative infinity to infinity. The whole piece is decreasing. Increasing, it never increases, so I would write it does not exist. Minimum, does it have a lowest point? Because there's an arrow, there will never be an end. It will continue going lower and lower, so there will not, does not exist. Same thing with max, see how it has an arrow? It will continue on and on forever, so a maximum will not ever exist. The domain is the left to right, so negative infinity to infinity forever for domain. Range is the low, so this was left to right. The range is the low to high, so the lowest is negative infinity because it continues down, and the highest it goes is positive infinity because it continues up. G of x. As I follow left to right and I read my graph, it is going up, it's increasing. It will never decrease, so it does not exist. Increase the whole time. The minimum, the arrow represents that there is no minimum. Does not exist. The maximum, once again, we have an arrow, which means it'll keep increasing, increasing, increasing. It won't touch the 0, but it's going to keep increasing, so does not exist because it will continue to change. The domain is left to right. My furthest left would be negative infinity. My furthest right is positive infinity. Then I will do low to high. My lowest value is an arrow, so it'll be negative infinity. On this one, it flattens out though at 0. so it won't go above 0. H of x. As I draw, it is continuing to increase. My entire section is increasing. This does not exist. My minimum, it continues down, does not exist. My maximum, there's an arrow, it'll keep going up, does not exist. Domain would be left to right. And my range would be bottom to top. It will keep going down and keep going up. For this one, from here to here, it is increasing. That is from negative infinity until -2. Then it is constant right here. So it is constant between -2 and 5. Then it begins to decrease from 5 to infinity. So decreasing from 5 to infinity. The minimum point, you will notice that there's an arrow here, which means it keeps going down, and an arrow here, which would represent it's going down. There would be no minimum. Now the maximum, I could pick all of these points along here are maximums. So I could pick one of them. So I'm just going to say the point 1, 2 is my max. 1 up 2 is my maximum point. I could have picked 2 up 2, 3 up 2, 4 up 2, 5 up 2, -1 up 2. I could have picked any of those maximums. My domain is left to right. My left number will continue to the left. My right will continue to the right, which means my domain is negative infinity to positive infinity. My range is my low number, which it will continue to go down forever because of the arrows on both sides, but it stops at 2. So my range would be negative infinity as my low, 2 is my high. And it hits 2 and flattens out at it, so I'm going to change this parenthesis to a brace. So this 2 is included in it. It hits the 2. That would be my range.